the basic integration techniques that should be remembered are to rewrite the integral as two sums. You could also make use of trig identities and to pay attention to inverse functions. You can use U substitution. You can make use of the log rule and also pay attention to the power rule. So with the first example, we're going to look at an example of rewriting integral as a sum of two parts, and we're also going to apply the inverse function rules. So as you can see, this integral can be written like this. And if you look at this integral here, you can see that you can have the derivative of u, which is x squared, in the numerator, but you're missing a 2. So you'd have to put in a 2, which means a 1/2 on the outside. So once you have that, you can raise the power and then divide by the power. So this could be written like this: 1/2 the integral 2x times so when you raise the power, divide by the power, you will get 1 over 2 times the square root of 4 minus x squared. And now we'll come to the second half of the original problem. For this one, we can rewrite it like this. Take out the 3 and then have 1 over. We're going to take out a square root of 4, so we can make this look exactly like the arc sine inverse function. When you take out a square root of 4, it becomes a 2 times the square root of 1 minus x squared over 4. Now we know that u squared equals x squared over 4, which means that u will equal x over 4, and which means that du will equal x over 2, which means that du will equal 1/2. And you can see that this 1/2 is already included here. So we're just going to rewrite this using the arc sine, which would be 3 times arc sine of x over 2 plus c. So that would be your answer for the first one. The second example is using the log rule. So for the log rule, you can add and subtract the same number to change how the integral looks. So in this case, we're going to add an ex and subtract an ex. So we're going to do 1 plus e to the x minus e to the x over 1 plus e to the x. So now I'm just going to split this integral, and I'm going to write 1 plus e to the x over 1 plus e to the x, which is this part, and then I'm going to put minus e to the x over 1 plus e to the x. This simplifies into simply 1, and then if you look here, you'll see that again we have u equals e to the x, and the derivative of e to the x, the du, also equals e to the x. So the derivative e to the x dx. So the derivative of the denominator is in the numerator, which means that this could be a natural log function. So I'm just gonna rewrite it again. Integrating 1 is just x, and then this would be natural log of 1 plus e to the x plus c. The third problem is to show an example of a disguised power rule. So in this case, you'll see that u equals ln of sine x. And the derivative for this would be, the derivative of sine would be u prime over u, which would equal cosine x over sine x. Now, using rewriting properties, this is just simply cotan x. So, as you can see, you have the derivative in your integral, which means all you need to do is raise the power, then divide by the power. So you're going to simply take the ln sine x squared ln of sine x, and you're going to square that, and then you're going to divide by 2 and then plus c, and that is the answer for that problem. Thank you.